So welcome, and thank you very much for being here instead of on the other more exciting sessions, hopefully. My name is Andrea Magnorsky, and you can find me in Twitter at Silverspoon if you want to say horrible things to me. So I do games. That's my day job. That's what I do all the time. For the last 2 or so years. Before that, I was in enterprise. So when I was talking to people here, mostly they asked, so what kind of games? And then I said, do you play games? And they were like, yeah, last time I played games was a long, long time ago. So instead of trying to explain what I do, I thought I'll show you what I do. This is a game I have in production. So I'm just going to play a little bit. You're playing this guy called Jiro. And you're a samurai. You're trying to save the world from the underworld that is emerging from Yomi and is trying to kill everything. So basically, you're fighting your own ancestral people, which is amazing, isn't it? By the way, in this session, I'm going to ask you a lot of questions. I will embarrass you, so I hope you do the very same, because otherwise I get really bored. After all, I do play games. So this is a very, very early demo, a very, very early alpha. But as you can see, there's a lot of animation. What's happening here? Animations happening all at the same time. You have AI for this monster. You have some effects. You have life going on the left up. And actually, you have a way horrible looking version of it. I'm just going to leave it there, but it gives you a better idea of what you're trying to do, which is you move a lot, try not to die. You're here, by the way, and you're trying to avoid this guy. You have to control the input on these things. You get the gist. I'm sure you played the game before. So that's enough of that. I know it looks amazing. So I'm going to get on with the actual presentation. Sorry. I missed this guy's called Vanguard. I gave him a friendly name that I'm not going to repeat because it's embarrassing. But yeah, we're very fond of him. So, as I was saying, Andrea Magnorsky, stuff, things. You've seen this, actually. I had to play the game because it was easier than anything else. So, I've been in enterprise 10 years. I've did all kinds of applications, I think, at least all the ones I thought I wanted to do. I did desktop, I did web, I did server-side. I also did getting really bored of life, and I didn't like that. At some point, I'm sure all of you do side projects, and one of the side projects was trying to start a game. And what I found when I started trying to write games, and not just a very, very small game, but a slightly bigger game, was that I was bumping my head against a very different programming way to code. So when, on all the other types of development I've done, it was all very reactive. It was like someone did something, and then you have to do something about what they did. So they click on a button, you do something about that. Someone requests some data, you go and fetch it from a database. Where in games, you have to do stuff all the time. The way I was playing, there was stuff happening. There was nice shades of stuff, things been moving on their own. It doesn't happen on its own, which is kind of sad. And the nicest the games look, the more difficult it is. So if you see a nice-looking game, they probably spend a long time crafting that. So this talk is a little bit about, it's a bit of a rant in some ways, hopefully, but it's also a bit of a thing about, hey, you know what? Whatever, the takeaway I hope you take, if I can't give you anything because you're all amazing and really smart, and I'm really scared because I really feel stupid in this conference, which is great because that's why we come to conferences, is that whatever you're doing, there's always some other different way to do things. There's always a new paradigm in programming that you haven't tried. You should go and try it because it's really fun. And the other thing is, whatever you're doing, try to learn it. in depth. For example, there is C# is a big language. It's really hard to know it well. I don't think I've done all of the C#, but I try. So, whatever you're doing, try as well. That was please remember this when you leave, hopefully. So anyway, now some boring stuff. How about you? Who of you made a game? Please raise your hand proudly. More proudly? There you go. So you're in the lucky kind. So what I'm going to do is just explain a little bit how this wonderful different programming model works. This is a humble game loop. I remember I was talking about real time. So what happens here is you initialize stuff. So you set some state. Then you move to loading content, sounds, images, other stuff that you might need to load, like models. And I'm not talking about, oh, hello, how are you? And I'm also not talking about data. I'm talking about like 3D models, if you use them. From then on, you're in a really weird thing to do, which is say while true, update, draw, update, draw, update, draw, update, draw. So that's what we're going to be kind of talking about today, most of it. In the update, you do stuff such as input, input analysis. So, I was playing the game. I probably pressed a good few of those input things in one frame. You have to deal with that. Just, it's not one input, it's multiple inputs. Do you want to deal with all of them? Do you want to remember for how long you pressed that? In certain other input systems, do you want to know how much pressure you apply to that? So it's just food for thought on how this is not, sure, games for schmoes. And then you're going to draw. And draw is actually really fun because you talk to the other processor in the computer that most people don't really deal with much, the GPU. This amazing piece of kit that most of us have a pretty decent GPU in your Intel integrated graphics, which is kind of nearly standard. So you're doing this. And finally, you unload if you want to. This is kind of a very standard C# loop. So, when you're rendering, you talk in general to either of two graphics kind of libraries there are. You either talk to OpenGL or DirectX, I don't know, people pronounce it differently. The limitation on this is that mostly whatever you do about multi-threading, when you go to draw, you kind of come back to a single thread because that's the way it works. This affects a lot on how you write games because there is a definite bottleneck. So, yeah, that's kind of cool. So this is a screenshot that actually comes out really well here from Skyrim. If you haven't, invest 30 or 50 hours of your life and do it because it's truly a really amazing experience. I think the games is an art form. And the key to that is that, I talked a little bit, I gave you a small snapshot of how technically complex games can be. But there is an extra layer of complexity added to this because when I say this is an art form, and I don't mean it in a kind of philosophical way, although we can go that way when we get drunk later on, the thing is that there is a creative constraint. So that means in my day-to-day job, I have two guys that are amazing artists sitting in front of me, and I have to make sure they are not blocked. But I also need to make sure that I give them as much freedom as I can. And think about this from a testing point of view. I mean, when you test, what are your conditions of satisfaction? Anybody wants to volunteer something? Any condition of satisfaction? One, please. I'm not going to keep going until you tell me one condition of satisfaction. So in a adding test, if you add 2 plus 2, what is your condition?
Not 3.
That's good. Okay. There you go. So you can talk. That's amazing. So what you have is deterministic. In a game, your condition of satisfaction, if you could write it, would be, it's fun. Write that test. It's really, really hard. Of course, you can try to kind of have the functional test. The game runs. The game has exactly these pixels here, which is some stuff you want to know. But from a functional point of view, which is how you test, you actually can't do it because you can't evaluate. Oh, yeah, it felt great. You actually need a human, which is kind of funny. So yeah, I'm just trying to show you how it works. So some challenges from a technological point of view. This and most games are trying to render at 60 frames a second. That means you have 16 milliseconds to do all the stuff I talked about, which is, it's kind of short, no? So error handling is different. Throwing an exception, is that even net? Why would you do that? You can't do anything about it. The game crash, and the game doesn't crash. That is the two very binary states. There's some subsystems that you can live without, but in general, this is what we're talking about. So, and this is all quite complex systems, and they're all interrelated, which makes them, again, as you can imagine, more fun and adds a lot of complexity. So it's funny to hear a lot of the guys talking here about complexity, and I'm like, well, this is hilarious. So I did this survey. I asked my game developer friends on Twitter. I don't have that many friends, apparently, because only 34 replied. To reply this really interesting 5-question questionnaire. And I said, what are you doing? How big is your game? So as you can see, how big is like generally small, because obviously small is faster, easier. And by small, it could be an app, okay? And by big, it could be a AAA game. Okay, so just so we have an idea of what we're talking about, because obviously complexity grows with size. So then I was kind of surprised. I said, this is the interesting one. 3 programming languages you use to write games. And this really kind of proves a point that was a lot of people think we only write C++. And actually, that's kind of why I made clear I write C#. And I could have done the same with Lua, really, but I know C# better, so I kind of went for that one. But F#, there's a lot of C++, ActionScript, Haskell, good few Haskell, Reactive Banana, I like that. I don't know, it sounds like fun. I should probably try it. AS3, whatever. So the funny thing that I found on this survey is that I said, after this, and I don't have a screenshot that big, I said, what elements of the language do you like about C#? And they said, it's a managed language. Okay. That's good, because you don't have to deal with garbage collection, but you have to be aware of it. Delegates. Okay, that's good, I guess. Link, they mentioned as well. And I started getting really worried. Because why would you use link in a game? So anyway, I'll proceed to that soon. Then C++, I asked basically the same question about C++. Why do you use C++? And the answer basically, kind of boiling down, I actually didn't put it because it was some answers were a bit crude, but they kind of said cross-platform and really good library support, which makes sense. But I kind of was sad. I was expecting, oh, there's this feature, and I love it. I love templates and to start a war or something, but that didn't happen. And then I said, what other languages do you use, and what features of those languages you use? And in that case, the response was a lot of dynamic languages. And that was a really pleasant surprise. And I think that was because most of us in game development, we do this thing where you have scripting at the top, and that's the bit that moves a lot. So, some positive things, some negative things, and this is my reading of this survey, so I could be completely wrong. So, I'm moving on to actually talking about C#. And what I'm going to do, just to kind of keep it slides and then code, is I'm going to go through my slides with some code and then go through some actual code. There's cubes that are amazing. They are so good. All game development demos are all about cubes. So anyway, delegate functions. Okay, if you don't know this language, this is kind of basically a callback. It's syntactically nice. There's func of some generic types of strongly typed. This is beautiful. I think it's good. It's nothing, I think if you know what this is, just use it. So I kind of thought, move along. But we all kind of know this. Now, this is contentious. And I put it here thinking, well, I hope for the best. Page down. So, link. Link is one of those features of C# that I think is nearly one of the best. I love it. So I'm sure if someone took a picture of this right now next to me, kind of go like, I would be embarrassed. So hopefully that won't happen. The things like, I try to think this way when I'm writing game code. And the reason for that is that generally link generates a lot of garbage. So if the size of whatever you're doing stuff with is, even bigger than, say, 20, maybe 50, don't forget that you're running this on, a lot of times every second, and yet your game sometimes can run for hours. How many times the garbage collector is called? So as a general thing, and particularly on my lower layers of our architecture, I try to think, do I really need this? Would it be better if I just use arrays and do stuff the old school way? And then I think, oh no, it's okay, I can use it. So contentious, I was hoping people would throw stuff at me at this point, but that's okay. We're probably no C# developers here, so I'm safe. I know this is, when I asked the thing about, in the survey I asked, please tell me what do you use, what are the features of the language you love? I really hoped that someone would mention coroutines, because it's really good. You can implement a very kind of cheap coroutine type thing with an iterator, but nobody said that except the guy that I work with. So that's not fair. So I assume all of you know what a coroutine is. Why they are useful for game dev? Well, it's because you can suspend the execution. So imagine you're running an animation. Remember when I was running my game, you had the demon doing crazy things and Jir also doing crazy things. So those are two animations. At a particular frame, they are a particular movement. Say Jir is like, and the demon is like, so at frame 16, he's going to be like this, and the other guy is going to be like that. The last thing you want is to keep state of everything you're animating, because again, think about all that memory you're using. And so suspending that is cool. So actually, I should have used this next slide. Because this cat is stately. See, it makes sense. Also, he's hilarious. Look, he's fat and everything. So how do you do this? Some code, because we all get bored without it. It's quite simple. You define a collection, an enumerator. So when in your update loop, you will call move next. You can call current, which is a kind of read thing, anytime you want. And it will only move to the next step on move next. I'll show you a demo. So this is more like, this is kind of how it works, and then I'll show you how it actually works. And then in the actual how to move on, in this case, you're going to change position of a cube. You're just doing this, which is creating a rotation. When I was telling you about maths and how we actually use them all the time, I wasn't lying. Matrix, vectors, we're so smart, aren't we? So when you have to return a value, you just yield it return true. You could return any other values. What you can't do is pass parameters, which sometimes is annoying. You can yield return in multiple places, and if you want to break, you just actually yield break. Any questions? Because everybody seems to get really excited about this. I don't know why. So what is an iterator? I decompiled the code because I thought it was interesting. Or people also thought it was interesting a few years ago when it came out. And so I put it here. It's a simple state machine. And I think that's good. It's also good to kind of read through this stuff when you're using it a lot, just to know that you're not crazy. Okay, I said that already. So this was Coroutines. This was the lightweight part of the talk. Now we're going to move to the bits that make my head hurt, and that was kind of cool. So remember I was talking about the update and the render. So there's this really, really smart dude called Carmack, John Carmack. I'm sure you know him. He kind of wrote a lot of code. Who doesn't know John Carmack? Because I'm going to do it that way. Everyone knows. Oh, one, okay. That's good. Well, so John Carmack, basically ID Software, he wrote Doom, which is kind of the first-person shooter game, and he got famous, and now he's working in Oculus Rift, and I think he's a genius. So anyway, he's not only a genius, he's also kind of nice in that he released a lot of open source code, and what I've done is I grabbed his double buffer implementation in C or C++, I can't remember, and no, C++, and I ported over to C# for your viewing pleasure. So what is double buffer? It's basically two threads, and while one is rendering, the other one is kind of filling up a buffer with render commands. What are render commands? Anything you need to render. In the code you're going to see soon, it's just a bunch of cubes with information about how you render a cube. So you fill this up. Once you're done, you swap buffers. There is nothing terribly complex except how to sync. So you know this in C# is going to obviously be very stateful. That also means you can fuck up royally. Can I say fuck up? Well, I just did. So syncing happens at very specific times, namely when you end, and also when you end. So here I'm kind of doing this beautiful representation. I love squares. They are so nice and defined. So the idea is that you see the different scenarios, and there's obviously more scenarios. So the first one was you create you pile up your render commands. Once you're done, you swap. In this case, you draw, but you finish before this is done. So the render thread will wait for you. Once you're done, you do this. And then finally, the obvious third comes when you do the opposite. You're taking longer to render than to update. It's very easy to make mistakes. And this implemented in C# is not long, but you can make mistakes very easily. The way you do that is you're looping here in the world. Obviously, you have the two threads. And you add the cubes. When you're done, you end the frame, you sync. And on the other side of this, you have you swap the buffers, and you loop on drawing. See the way I draw. This is the key. So, you know, why would you go through this amount of, you know, why would you do that implementation? Because we have multiple cores. I was hoping, again, I don't know. I imagine these talks all so different. I hope they are a little bit better than I hope. Anyway, so why would you go through this really hard work of implementing that? Because synchronizing stuff is painful. Why would I not just do a nice immutable thing that all talks to each other, and there's hugs and our rainbows and ponies? I don't even have ponies in my slides. It's terrible. And the reason is that you actually, even with this really, old implementation from Carmack, you get really good performance. And you know what? Games are about performance, not about ponies. Although some games have ponies. So what you do, I probably should do a game about ponies soon. So what you do instead is use concurrent collections. See, I like cats instead of ponies, I'm sorry. So all you're doing is, instead of synchronous, it's really hypnotizing, isn't it? It's great to see you guys doing this. So instead of writing the synchronization code, you let the concurrent collection do the tough job. And you do that, but it's really simple. I show you in the code. It's like, even if you don't write C#, you could understand why would you choose one. You pay with performance, though, because the threads, when you're using these collections, are really waiting. So I kind of did the analysis while I was explaining this. So the comparison. This is the tough numbers. On double buffer, here the thread is sleeping. So I can use the processor for anything else I want. This is the other one. And I tried with different kinds of collections, which is kind of sad. I expected better. Actually, I should probably slide this. It becomes better as I'm going, but it's not very good. Still better than using just one thread, but not great. So what I'm going to do now is show you some code so you stay awake, because it's really warm. It's so warm when you're talking. OK, so I'm going to show you this iterator code. It's quite simple. And again, please ask questions, because I don't know how much, not understanding this is totally cool. I won't think you're stupid or anything. I actually think you're really smart if you're a question. If you ask questions, you're probably a genius. Just saying. Yeah? So I'll come back to where we're in the world. In game, sorry, I'm using XNA because it's easy to demo with ourselves. We're using another engine called Duality, which is open source, and it's really nice. So in this game, this is how you write a game in XNA. I will create a world. Can you see with the size of the screen? Yeah, cool. I update it, I create it. When I create a new world, I have a renderer, and I initialize it. And this is the interesting part. So I have 3 enumerators, right? And I have one that will actually coordinate the other 2, just for the crack. And I put different types just to show you that you can use different types. And if you don't use a generic type, it won't work. So just saying, in case you're going off to write this immediately. So when we're initializing, I define this, which all it's doing is move next. And then when I define this, change position, for example, I kind of call a method just to make it nicely separated. And we're doing this while true for each primitive, keep rotating. Now, the color one is more interesting because can anybody tell me what will happen? Just so guys, I check for your being awake. There's 2 things that will happen. The times are, this is time in milliseconds.
Every 5 milliseconds, it will change color.
OK, cool. And you nearly had it. You had a thought there. Oh, what's happening?
It's like 4 colors.
Cool. And then that's good. And then after 5 seconds, I'll stop. I'll just say, no more changing color. This was an awesome party, but it gotta go. So how it looks for an amazing looking demo. So it changes color, rotates, moves around, and then it stops. It does what it should do. The funny thing is, like, coroutines are actually quite useful in not only game development. So, there you go. So that's one demo out of the way. Now you learn how to do coroutines really cheaply in C#. However, if you wanted, there is a really good coroutine library called Flow. It's basically using these concepts, but taking it a little step further, and has features and kernels, and it's actually quite good. And it depends only on C# too. So check it out if you're interested. I was going to show it, but I didn't see the point. So the next one is this double buffer implementation. No, I should probably, sorry. So this is where unless you're used to concurrency, this is painful. Okay, and yeah, I don't know. I don't want to inflict pain, but it just happens. So you have two lists of render commands. This is the interesting ones at this point, and this is remember the two diagrams we had, the red one and the blue one. So this is kind of filling up the red one. Okay, so you're just going to add a bunch of cubes to buffer render command. Say when it's ready, it's going to give it to the renderer and draw it. And meanwhile, you're going to keep filling B. At the same time, now switch a context to your thinking brain, and you're going to have these 3 lines of, 3 manual reset events. And you need 3 thinking things, because that's the way it is. Maybe after we do this. So what happens is, when you're adding a cube, there's no thinking, which is good, because you don't want that, because otherwise it will lock all the time. However, when you're done, you do this bit of thinking. So you're saying, I haven't completed render it. My commands are ready, and I don't know if I'm ready. I'm not sure if I'm ready to render or not. So it's nice to have the code organized this way, because after end frame, in your brain, you kind of generally go here, which is draw, because you finish pulling all this stuff, and you're going to probably want to render something. And you're going to come here, and you're going to say, kind of open the door for the render active, say that you haven't completed this, wait for render commands, because this is kind of what's stopping you from starting to add more render commands. Here you swap the buffers. Remember we had that bit where you swap the buffers after you fill this up. So this happened just before drawing. And once you've done that, you say, OK, now I can go and render stuff. And off you go, render happily and merry. And this is why this stuff is here. Because just after you render, in the context of how this can happen, don't forget these 2 threads can be on different parts and sections of the code at different times. And explaining this and I tried explaining this in different millions of ways, and it's always confusing. I always feel like I'm leaving something out. And the reason for that, after thinking about it, why is this so hard to explain concisely? It's because it's just a complex problem. And hopefully we shouldn't need to do this, but we do. So it's just better to leave it as tight as possible. That's my analysis. I hope someone tells me wrong or something. Now, compare this with that fire truck or ambulance. Goodbye. Sorry, I had to let that go because it's pointless. So that's kind of complex. And obviously, I'm showing it here. It's like, yeah, sure, it's done. That's great. But it's kind of hard to write if you have to write it on your own. And in game development, this is actually funnier, because here we're an open community. We talk about stuff. If I have problems, I go like, how do I solve this? Do you know? And you'll be like, well, I don't know. I did this. Maybe you'll try to help. In game development, in person, yes, people are like that. But it's rare that there is shared code in places, and I find that a little bit frustrating, and I hope that we can change that. I'm talking to you as if you were like game developers, and I hope you are. And if you're not, you should be, because it's great. It's really fun. But it's also really hard, and blah, blah, blah. But so anyway, compare this to this other solution when I use a concurrent queue. So basically what I have here is, instead of 2 buffers, I have a concurrent queue of render commands. So the way to think of this is that every item on the queue, which in this case is going to be limited to 2, and that's the key for why this is not a great solution. So every item in the queue is what you're going to render. So it's a whole frame. Okay, so you have the whole frame ready in one of these items of the queue. Just keep that in mind. So what you do is, okay, I'll just highlight it so it's easier to see. You renew it up. And once you end the frame, you have the same scenario, exactly the same. Once you end the frame, you say, enqueue this. And when you're drawing, you're trying to dequeue this. And then you're off and drawing. I'm feeling like it's kind of self-explanatory. So if I'm leaving stuff out, please shout. And this is the key of why I wish there was a better solution. That there might be one, but it will make the solution as complicated as before. You're limited this to count 2, because we're doing double buffer. So at the same time, this still gives you a win on okay, it's not doing what I want. Sorry. So, okay, the reason why we're limiting this to 2 is so there's double buffer, and you are just adding 2 instead of millions, which could happen. Because, again, you have 2 threads. If you let this go wild, you probably run the update loop, like, I don't know, hundreds of times. And so you don't do what you should do in the draw. You just draw something random, which it would be terrible. So this is what you produce. Actually, trying to render this without the 2 threads, my machine would complain. It would go into some sort of. So that's nice and smooth. So yeah, that's interesting. Some other cool. Actually, I should move back to this. Interesting. Okay. Sorry about this. This is why I bunch up all the demos in one. I'll just finish off this way. Yeah, it's actually all on GitHub. There's a library. I'm Andrea on GitHub, and this library is called C4G, so it's C# for games. So yeah, please have a look and let me know what you think, or if you want to, anything, change it, play with it, transform it to F#. No problem. I actually took a bunch of slides off, which I kind of regret because I had no idea how this will flow. Any questions? Like, please. Again, if you ask a question, you're a genius. Amanda is a genius. I don't know that. No? Okay. So I actually blogged about this concurrency stuff in my blog, roundcrisis.com. It's called like that because I had a band, okay? Stupid, just get over it. And my company, where I work and do that game that I showed you, is called Packet Games, but we also run their digital furnace. But Packet Games is the one that most people know me from. This is a really cool cat. As you know, I like cats. I actually compiled a bunch of references in case you want to go deeper in this bundle, which is actually kind of easy to remember. Bundles, bit.ly.com, bundles, round crisis, and the number 3. So you should go and check it out. And also, please give out to me if there's more things I should add. And I don't know. Since you're not going to ask questions, I'll stick around for a little while. And thank you so much for being here. Cheers.